Hello, class. This is a recorded lecture for section 2.3. And this is not only an important concept in trigonometry because there's tons of real world applications, but it's also a challenging section. This is the section that we're going to talk about graphing sine waves and cosine waves. Those are ones that show up in the real world all the time. Our lives are dictated by having our power distribution using sine waves that get you electricity to everywhere you're at here in the United States and all over the world. And so for me, as an electrical engineer and doing power distribution, I did this all the time. And so what we're going to do is walk through kind of a step-by-step approach on how to sketch a sine wave and a cosine wave, and walk through three really important parameters with regards to the sine wave and cosine wave. The other graphs we're going to touch on a little bit. That's the next section, but I can guarantee you that this is by far the most important. And also you will see again on your quiz on this and your first exam as well. So the idea first that we want to talk about is the behaviors of the sine and cosine wave. And what's hopefully that you've realized that we've talked about with the unit circle approach especially, is that after you have an angle that is 2 pi, things repeat itself, right? And so an idea to look at this. Book uses this letter T again, which is an angle. A lot of other books use theta, but I need to keep using. So if you had sine of the t, which t is an angle, the idea is that you think about the unit circle. Let's walk through a few points. So what happens when t equals 0? Well, you're on the unit circle. This point here is x equals 1, y equals 0. So if you think about, remember, sine is the y value, right? So sine of 0 would be 0. So what happens when we're at t equals 90 degrees? When we get to 90 degrees, or pi over 2, if you want to do radians, and we will do radians, so let me do both of those. We have x equals 0, y equals 1. So what would be sine of 90 degrees, or pi over 2? That would be the y value of the number 1. So what happens at 180 or pi? That would be x equals minus 1, again, y equals 0. So you could see that sine of 180 degrees, again, would be 0. So what happens when we get down to 270? Well, when we get down to 270 degrees, that would be 3 pi over 2. And then that point on the unit circle is 0 minus 1. So if you think about that, that would be sine of 270 degrees, and that would be minus 1. And then what happens when we get back here, which is 360 or 2 pi? That ends up being sine of 360 degrees or 2 pi, and then we end up back at 0. And then you can see if we add another 90 degrees, so instead of being 360, that would be 450 degrees. We start the process all over again, right? Sine of 450 degrees, again, is 1, and so on and so forth. So the way that we actually, let me erase this up. The way we actually graph this thing Sorry about the delay here, but it takes a while to get rid of all this, is we graph it again on a Cartesian coordinate plane, where this value here is the value of the sine wave. And let's put, this would be +1, and this would be -1, and this would be t. So this would be the angle that we're talking about. So let's do it in degrees, and then the next one we're going to do in radians. So this would be 90. This would be 180. This would be 270. This would be 360. This would be 450. And the way that I like to do that is that there are 5 main points. First of all, where does the waveform start? Well, we start at 0, 0. And then what's the highest value? What's the lowest value? And where does it cross on the t-axis, i.e. where does the value equal 0? So you can see at 90 degrees, we go up to 1. 180, we go down to 0 again, 270. Back to where we started, 360. And you can see, and what you'll see is that this thing actually goes on forever, just like a lot of other equations in the math world, right? And so the first of the 3 parameters that we want to introduce is this idea of a period. And probably the first time in a math class that you've talked about periodic equations, and these are functions, so periodic functions. And what we mean by that is they repeat over and over again after a certain period of time or over a certain angle. And as you could see on the graph that I showed you, that both the sine wave and you'll see the cosine wave as well repeats itself every 2 pi or 360 degrees. And that's what we call the period. And depending on what the equation looks like, the period could change. But the standard equation, sine of t or cosine of t, as we have here on the whiteboard, this period is 360 degrees or 2 pi. And you'll see that when you do the WebAssign homework, they like to use radians. So what I'd like to do here is to put the radians up here. So this would be pi over 2. That would be pi. This would be 3 pi over 2. And that would be 2 pi. And this would be 5 pi over 2. And so on and so forth. So you'll be able to go back and forth with regards to that. So first, very important concept, this idea of period, that this waveform repeats itself every 2 pi in this case, with 360 degrees. And one of the reasons why this waveform is really valuable in power distribution is an AC voltage and an AC current is easy to distribute at long distances. And so that's why the sine wave, if you've ever watched the movie Current Wars, there was a debate between Tesla and Edison, and Tesla won. And the alternative way of distributing the power is definitely much better in the overall scheme of things. And so our first definition is given by this idea of a periodic sine wave and cosine. So the function is periodic over the value of 2 pi. And when you go 2 pi distance around the unit circle, or if the angle goes from 0 to 2 pi, you could see that you end up starting at the same place again. And hopefully that this table here is not something that surprises you, because we've been talking about this now for the last few weeks. And this is the sine of t is the y value going around the unit circle, and cosine of t would be the x values all going around the unit circle. And you could see that pi over 6 would be 1/2 for sine, and so on and so forth. But the cosine, it starts at 1, right? So it's at angle equals 0. If you remember on the unit circle, that value is 1. And so let me show you a couple graphs that are prettier than what I did. But you can see exactly the same. So over the one period, you can see that the first graph here gives you a nice detailed explanation from 0 all the way to 2 pi, splitting up every 30 degrees, or pi over 6. And then you can see the one that I did on the whiteboard is the second one. Here's what the cosine graph looks like. And you can see that the cosine, instead of starting at 0, starts at 1. And the first graph, again, illustrates the cosine in 30-degree increments. And the second graph shows what I did, where what I like to call the 5 main points. The highest point, the lowest point, which will be called the amplitude, and then where it crosses the x-axis and where it actually starts. So those are really the 5 main points. And so here is the 5 key points that we talked about. Where it starts, that would be right here in the sine wave and right up here on the cosine wave. And then the quarter point would be in the sine wave would be the highest point. And here the quarter point is where it first crosses. And you can see the halfway point on the sine, it's where it crosses. And the halfway point is the lowest point. So I think you see what I mean, is that we're looking for 5 key points with regards to, excuse me, with regards to sketching these graphs. And that's what I'm going to be asking you to do with regards to sketching a sine and cosine wave. And so looking at this sketch that I did, this is the first key point, which is where we start. Here's the second key point, that's the highest value. Here's the third key point, where it crosses the angle axis or the horizontal axis. Here's our lowest point, key point number 5. And then here is where we start again, which is, I'm sorry, key point number 4 was the 270, or 3 pi over 2. And then the key 5th point is where we start again. And then you just repeat this over and over and over again. So what we're going to focus on is, given different versions of these equations, how to find those 5 key points. Okay. So I think this is a good place to stop the first part of this lecture. I'm probably going to split it into 3 different lectures, recorded lectures. So the next one we'll move on to talk about amplitude and phase shift.